graph of sine and the graph of its best friend, which is cosec. Okay, now let's do the same for, this is not even hard, let's do the same for cos. So we want to see what is the graph of, so we can put here to say this is this graph that we have is the graph of y equal to cosec x. Wow, beautiful. Now let's do the graph of y equal to cos x. What is it that we need to know? Oh, we need to be very good at just putting the important values. Okay, first of all, that like before we even do anything, we should just ignore any other value. The values which we want are 90, 180, 270, and 360. Okay, and we put it as, if we want a 90 in radians, it's going to be pi over 2. 180 will be pi. 270 will be 3 pi over 2, and 260 will be 2 pi. Okay, if you want it in red. Then here, this is negative pi over 2. Then this is negative of pi. Then here it is negative of 3 pi over 2. Then here negative 2 pi, but they don't want it in this, but in the question that we're going to be doing, but we can just put it as a negative 2 pi. We still want it. Okay, then we'll see how to remove that part. Now, anyway, remember that the graph of y of sine x and cos, they never, these two graphs never pass the value of 1. So that means here it is going to be 1 and minus 1. Let me put it down here. Okay, minus 1. Then here is my 1. Okay, now let's get to work. Y equal to cos x. How am I going to plot you? With the calculator. So easy. So make sure your calculator is in red. Okay, mine is in red. You can say cos 0. What do you get? You get a 1. So it starts at a 1. Okay, so this is not even hard. We start at a 1. Then now you say cos pi over 2. Okay, cos open bracket pi over 2 close is equal to 0. So it's now going to come here. Then of course we now know that it then comes on pi, it comes to minus 1, it goes back to 0. Then on the next one it goes to 1. You can be punching, just punch there to say cos of pi, I'll get a negative 1. Is that what I have? Yes, cos pi is a negative 1. Then cos of open brackets, I say 3 pi over 2. I got a 0. And then I can say cos of 2 pi now, close bracket, I get a 1. So this is just what happens. Okay, now this 0 is not supposed to be there. Okay, sorry for that. So let's finish it up. We don't want the 0, the purple 0. It's confused. All right, now here it's from 1 it comes to 0. From 0 it goes to minus 1. Then from minus 1 it goes to 0. Then from 0 it goes back to 1, which is going to be here. So that's just what happens. And when you draw with the pencil, it's going to be like this. Then it curves here. Make it curve nicely. Then come back up. Then you start curving here. It curves down, goes back down like this. Then curves, goes back up, and curves. What a beautiful thing. Look at it. Very nice, isn't it? And very easy as well. 1 to minus 1. How do I remember? Remember the 90s, okay? 90, 180, 270. Those are the ones we want when we plot. Those are the important values. So you can come here and say, this is my graph of y equal to cos x. Now let's do for y equal to sec x, because we need this cos for us to be able to do the 1 for sec. Let's come and let's put it now. So here we can have it. This is a negative pi over 2, of course. This is a negative pi. Then this is a negative 3 pi over 2. Then this is a negative 2 pi. But of course, in the question, they don't want it, but we're putting it for now. Then this is going to be a pi over 2. Then here a pi. Then here a 3 pi over 2. Then here a 2 pi. Now, we know it doesn't end at 1. It's at, no, that's a different one, because now we're doing the 1 over. Now, how do we do it? Remember, we said, look at the points where it goes to 0 and put them as asymptotes. So here I have asymptotes here, okay? They are different from those of sine x, okay? This is another asymptote of mine. Here, it's not going to 0. It's actually going to 1 on this axis, so it's not. But on pi, at pi over 2, we have an asymptote. So we have an asymptote here. Then, of course, another one after 2 positions like this. You can just put it, because that is where it's also going to 0. Now, what do? Well, we just go where it starts. So here it is a 1. So we also should have a 1. We also go to a 1. So a 1 is 1 here. And if we go down 1, 2, 3, 4, this is a negative 1. So here we're starting at a 1 on this position. But since here it's bending down, for here we'll bend up going to an asymptote like this. Okay, that is what we do here. Now look at this one. Where is it? It starts at a minus 1. you go to -1 again. Go where it is here. We want that. At this negative pi, it's at -1. Then since here it's facing up, it's like this. We make it face down. So it's just going to be here facing down like that. Then again, where do we go? We go to 1. So we'll be at 1 here. It's facing down. So we make it face up. Okay, so now we have here at -1, it's facing up. So we go to -1 and we make it face down. Then now what we have up to 2 pi, it's just a curve like this. You can see it. Okay, so where is it going to? It's going to 1. So here at 2 pi will be at 1. But now you can see this is curving, going down here. We curve going up, going back to the same thing. Okay. So this is going to be it. This is going to be a graph. But now remember that they want you to end at 3 pi over 2. For the question which is coming, oh no, here they say -5 over 2 to pi over 2. Okay, so anyway, we'll see what it is. But this is the general shape, and this is the graph of y equal to sec x. Then we'll now see which provisions they give us. Okay, these are the curves of these two, y equal to sec x and y equal to cos x. Okay, that is it. Goodbye for now.